Welcome to Statics Lectures by Civil Thinking, and today we are going to solve a problem on equilibrium of rigid bodies. Now before I move on, I suggest you to please watch the video lectures on equilibrium of rigid bodies in sequence one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's problem. Now now this problem says we have a vehicle. Okay, this the green box is a vehicle, but unfortunately we only have two wheels. Okay, two tires A and B. We only have two wheels A and B, and it is on a sloping road. This is a road. Okay, and it is inclined at an angle of 30 degrees. Okay, the angle is this angle is 30 degrees. Okay, the slope of this road is 30 degrees, and the tendency of this vehicle is to move downwards, right? Like this, it wants to move because it's on the sloping road, but it is at rest. Why it is at rest? Because this vehicle is fixed to this fixed object. Okay, this is fixed object. This vehicle is fixed to this object with the help of the cable. Okay, now you can see the vehicle is in rest, means it is in equilibrium. Now because the vehicle wants to move downwards like this, so there will be a tension in this cable, right? Let us assume that tension in the cable is like this. It is T. Okay, we have to find this T. Okay, now we also have to find the reactions at A and B. Okay, so reactions, now these tires, these wheels, they are roller supports. Okay, and in roller supports we only have one reaction, which is normal to the surface. Okay, let us say this is Ra, and let us say this is Rb. We also have to find these Ra and Rb. Okay, we have to find the value of Ra, and we have to find the value of Rb. Okay, that's all what is asked in this problem. Okay, now because all of this system it is at rest. Okay, it means it is in equilibrium. Since it is in static equilibrium, it means we can apply the equations of equilibrium. Okay, please note that this is a 2D diagram and this is a 2D body, so we will only use three equations of equilibrium. Okay, we will use summation of f of x is 0, summation of f of y is equal to 0, and summation of moment about any point is 0. Okay, because this is a 2D figure, we have to use only three equations of equilibrium. Okay, now we will apply them one by one. First we have to decide which is x direction, which is y direction. Okay, so along the road, okay, this is road, along this road, okay, this is x-axis, and normal to the road, okay, normal to the road is the positive y-axis. Okay, I have chosen this x-axis and y-axis. Okay, now the mass of this vehicle is 200 kg. It means this vehicle have a weight too. Okay, I mean we have to consider the weight of this vehicle too, right? Now the weight of the vehicle is always perpendicular, right? Weight of anything is always perpendicular, something like this, right? This is the weight, right? Now weight is mass of the vehicle multiplied by acceleration due to gravity, right? Now mass is 200 kg multiplied by g is acceleration due to gravity, which is 9.81, right, meter per second square. Now how much is it? Let me use a calculator. 200 multiplied by 9.81, it is 1962, okay, Newton. So we found the weight of this vehicle. Okay, 1962, right? Now we have to apply summation of f of x equals 0, summation of f of y equals 0, summation of moment equals 0. Then we will be able to find the value of t, ra and rb, right? Now when we apply summation f of x equals 0, we will consider all the forces in the x direction. Now which is the x direction? x direction is along the road, means like this, right? The t is in the x direction, but as you can see here, w, it is neither in the x direction nor in the y direction. So when we apply these equations, because we will apply these equations along x direction and y direction, so we will resolve w into x component and y component, okay, so that we can consider w in these equations. Okay, right now we cannot consider w in these equations because this w is in no direction, right? So we have to resolve w. Okay, so let me change the color first. Now let us say this is the x component of w. It is x component of w, and normal to the road like this, it is the y component. Okay, so this is, let me erase it, let me draw it a bit longer. This is the y component. Okay, now how much is it? It is w. Now the angle here is 30 degrees, it means this angle is also 30 degrees. Okay, 30 degrees. This is w, right? This vector is w, right? Now the angle is 30 degrees, so it is w cos 30 degrees, right? And this is w sine 30 degrees. Okay, now w is 1962. Okay, so let me simplify these two vectors. 1962 multiplied by cos, it is 1700 Newton. Okay, now w multiplied by sine 30, how much is it? Let me use a calculator. Sine 30, it is 981 Newton. Okay, okay, now let's apply these equations one by one. Now let's apply first summation f of x. Okay, now summation f of x is 0. Okay, we will apply this. Now summation f of x means sum of all the forces in the x direction. Okay, so since this is x axis, okay, it is towards right is positive x axis, so anything against this opposite to x axis is negative. Okay, now t is opposite to this, it is negative, so minus t, because t is in x direction. Okay, we are finding forces along x direction, that's why I consider t. Now w sine 30 is also along x direction and it is along the x axis, right? So it is positive, plus 981 is equal to 0. Okay, so from here I will get the value of 981 Newton. The tension is 981. Okay, so we find the value of tension. Okay, now let me erase this first. Now let's apply second equation, or let me first apply the third equation. I will tell you why. It doesn't matter. Okay, it will just save my time. Summation of moment equal to 0. Okay, let's apply this equation. Now summation of moment about any point, let me choose the point B. For example, summation of moment about point B is 0. Okay, I am assuming the clockwise moments, they are positive, and the anti-clockwise moments, they are negative. Okay, now at point B, these are all the forces. Now T is going to exert an anti-clockwise moment, right, at point B like this. So I will choose negative here. T multiplied by, how far is T normally from point B? It is this distance, 2 meters, right? T is this, and the normal distance between point B is here, right? This is point B, so the normal distance is this, right? It is 2 meters. Now let us find the moment at B due to W sine theta. Now W sine 30 degree, it is going to exert clockwise moment at B, right? So it is positive. W sine 30 is 981 multiplied by, how far is this W sine 30 from point B? It is 2 meters, right? Multiplied by 2, right? So we find moment due to this. Now let us find the moment due to RA. Okay, plus RA, because RA is going to exert moment like this, right? It will try to move like this, so moment due to RA is positive, which is RA. How far is RA normally from point B? It is this distance, right, which is 2 meters. Now what we are left with, this W cos 30 degrees. It is going to exert an anti-clockwise moment at point B, right? And W cos 30 degree, it is at a distance of how much? How far is from this point to this point? How far is this? Now the total is 2 meters, so from the center of 2 meter to the this point it is 1 meter, right? So negative W cos 30 is 1700 multiplied by 1 meter, right? This is summation of moment, all of it is equal to 0. Okay, now T is 981, so I will put 981 here. RA, we have to find this value. Now let me use the calculator to find these values. Now negative 981 multiplied by 2 and plus 981 multiplied by 2, they will cancel out each other, right? Because this is a positive term and it is the same but negative term, so they will cancel out. Okay, so let me just simplify it. So we are left with RA multiplied by 2 minus 1700 multiplied by 1. Now 1700 multiplied by 1, it is 1700. Okay, it is equal to 0. It means when I put 1700 to the right, we get what we get. We get simply RA multiplied by 2 is 1700, right? Now from here I will get the value of RA to be 1700 divided by 2, right, which is 850 Newton. Okay, so we found the value of RA to be 850 Newton. Okay, we've applied this equation and this equation and we got this value. Now we have to find the value of RB, right? So let me first erase this. Now let's apply this equation. Summation of f of y equal to 0. It means sum of all the forces along the y direction. Y is this direction, right? Normal to the road, this direction. Okay, now I'm assuming the upward forces, they are positive because y-axis, the positive y-axis is upwards. As you can see here, it is upwards. So anything along this direction is positive and anything downwards like this, that is negative. Okay, now what forces are in y direction? Now RA and RB, they are in y direction, right? So it is RA plus RB. What else? Yes, this W cos 30 degree, which is 1700, and it is downwards, right, opposite to this, so it is negative minus 1700. There is no another force along the y direction, so all of it is equal to 0, right? So I will equate it to 0. Now R is 850 plus RB, right, minus 1700 is 0. From here I will get the value of RB to be, I will take this term to the right and this term to the right also. So this is going to be positive, this is going to be negative here. Now 1700 minus 850 is 850 Newton. Okay, so we got the value of RB to be 850 Newton. So we got T is 981, and RA and RB, they are both 850. RA and RB, they are both 850. Okay, so option C is the correct. Okay, so this is how we solve the problem on the equilibrium of rigid bodies. We just use the equations of equilibrium: summation of f of x equal to 0, summation f of y equal to 0, and summation of moment equal to 0. Okay, so in case of static equilibrium, we apply these equations to find the unknown reaction or anything. Okay, so that's it for today. If you have any doubt, please comment, and see you in the next class. Thank you.